Hi. Wow, it works. Awesome. I am Jonathan. I am the manager on New Relic's mobile engineering team, where we don't build apps, we build things that go in apps. Yeah, quick poll. How many people here actually deal with mobile applications, either building them or managing them or nice? About 50-50 maybe. I'm kind of blind from up here. So, wow, there's so much out in the world in mobile. 6 months ago, we released a first of its kind system for monitoring the actual network interaction from a phone, seeing how it connects to the world. And it turns out that this is something people are really interested in. We had, a few thousand apps in production using New Relic for mobile. We monitor over 100 million app installs every month. I think right now we're processing something like 5 million network requests per minute. And so apparently apps actually talk to the world a lot, and that conversation matters. So in a world that runs on software, as Lou was talking about this morning, if you caught the keynote, there's, having confidence and predictability in your process as an engineer and in what you do is a critical thing. The confidence and predictability, those two things keep your clients and your business partners and your bosses happy, right? They allow us to plan our lives so that we don't stay up all night trying to fix a problem we didn't anticipate. And most importantly for me, I think they make our users believe in us, right? I was just talking to someone who said they've seen data that says if you have a really bad mobile app, but you're really responsive to the people who talk to you about the problems they have with it, you'll get a higher rating in the App Store than if you have this fantastic app that is perfect, but you just never talk to your customers. That, understanding what your users do and what they want out of life is really critical. And the only way to make them happy, which is what makes me happy, is to have that understanding to be able to anticipate their needs. So I know this was supposed to be a talk about all of the big data that we've collected at New Relic, but I had another idea that I really wanted to share with people. I wanted to talk about some of the unique challenges that we face in mobile development because of the kind of constrained environment we have, and talk about what we can maybe learn from the way people are doing things in the web app world and translate that into mobile. And my hope is that in a half hour, you'll have something new that, some new insight or some new thought that you can take back to your practice building and managing these mobile apps. And then we can go get coffee and snacks and stuff, which I think is why I'm here. But so mobile applications, I actually started, a year or two ago thinking about them as massive distributed systems. Just kind of, if you take a step back, you've got this software that is actually massively concurrent, right? It's running on millions of hardware nodes all over the world with these really crazy multi-tier, multi-party architectures that no one can control. You talk to all sorts of services that are outside of your control, and you kind of just hope that everything works right on devices that you have no access to. These apps they're just literally running wild, right? Like a herd of wildebeest. And with no monitoring and no possibility of managing the phones that they're running on or tuning things, how can you grapple with that and expect the app to give someone a good experience? Our apps, they talk to one another, they talk to the world, and at the very best, we have a little bit of very basic insight that comes from things like watching the App Store comments or the little traces they leave in places. A great example of this, I think, is the app we built for FutureStack. Right? There are no wildebeest here, but you are wearing a computer running a mobile app. And it talks to like 800 other nodes, pretty much just like it, over two completely different sort of communication channels, and a server. Not too hard, but you also have an app on your phone, right? And it talks to the server over Wi-Fi and over all these different cellular networks, some of which are really good down here and some of which are really not good. And it talks to hundreds of other nodes running that same code base, right? But each of them's a little different. It's got a different person's name in it, and it has a different set of contacts. right? And then it talks to hundreds more that are the same, except they're written to the same spec in a different language for a different platform, right? So they're really completely different software. And they talk to all the nodes that are hanging around our necks. And they're also actively sensing our environment, right? Collecting data from things like posters. And traditionally, the only thing we can actually monitor and manage in this entire platform is a server. One server out of like 1,600 nodes, right? And it's just a little app that is for a conference. It's complicated, but it's not as complicated as the stuff we build every day. So how can you take responsibility for all of this, right? When you can't log into the machines your code is running on, you have no idea what the data is that they're processing. At New Relic, we live and breathe this thing we call instrumentation, right? The ability to see what your code is doing in real time out in the production world. And the more you instrument, the more data you have, and the more sense you can make of what's happening and make better decisions about how to improve things. Some of you may have looked at our platform, right, where our plugin platform, where you can take all of this great stuff out in the world on your server or elsewhere and pump it into New Relic and see it all in one central place. Our platform team, I think they have this kind of unofficial motto of sorts, right, which is instrument all the things. Everything you can see, just get it in there, and then you'll be able to make sense of your world. But seriously, for mobile, how do you do that? How frustrating is it to get a bug report and spend hours trying to reproduce this weird case that you have no idea how someone got there? And imagine how bad it is for the user, right? They don't know how any of this is supposed to work, much less what's going on underneath. So they must, honestly, sometimes I think they just look at us and are like, I have no idea what you're talking about. You don't believe me, right? And it's not that we don't believe them, it's just we have no way of knowing what's going on with them. So in the web world, there's this thing we've been talking about for a few years called DevOps. And for those of you who aren't familiar with the term, or those of you who have seen 3 different terms and 3 different marketing pitches from 3 different companies, I think the idea is fairly simple. I would summarize it as saying that by increasing the communication between your developers and your operational experts, you can reduce the length of a feedback cycle in pushing out your software and reacting to changes that it makes. And that allows you to absorb the risk that comes with iterating more often. So the more often you go through this loop of agile development and iteration and pushing out your changes, and the tighter your window for catching problems before they release is. And as that window shortens, there are bugs that you're just not going to catch, or performance impacts that your test systems just don't anticipate. And so you need a better way to react to that stuff, or else the service that your customers get will start going downhill. So with DevOps, by allowing everyone to kind of talk together and bringing both the developers cycle going out and the ops cycle coming back in, from the developer perspective, obviously from ops it's the opposite direction. You allow yourself to do that. But in mobile, the DevOps team has to be accountable for both the functionality and performance of their application. Right? Traditionally, the developers do the functionality and the ops team does the performance. And in this case, it becomes much more of a partnership. You get a real understanding of potential problems coming from the developers to the ops folks so that they can anticipate that, spin up more servers, tune the database, whatever they need to do. And then the reverse cycle is that as soon as code hits production, if you've got good ops people and good instrumentation, they can see what changed with that software. And they feed that back to the development team, who can adjust and fix problems and continue to optimize things. And it's that fast cycle of feedback that really makes life livable. And it allows you to iterate and innovate much more quickly. So as a mobile developer, you're held accountable for the performance of your product, right? The functionality and the performance of your app on hardware that you can't touch. So how can you have that confidence and predictability that lets you stay sane when you don't have an operations team and you can't log into the servers that your code is running on, right? I mean, we know that you should avoid things like premature optimization and instead focus on profiling and improving the parts of your code that actually suffer under runtime conditions. And we need to do that same thing in production and mobile, which means we need to... Thank you. I think that was a new Relic guy. But so if we can watch what's happening in these apps out in their native environment with kitties, and see how the data actually talks to the user and the network and how the app is moving back and forth, then we have information on what's not going the way we expect it to. So to me, it seems like basically we need to find a way to turn the app itself into the operations team. And we could call it DevApps if you want a bad joke. So if we teach the app how to monitor and report itself, then we have this great partner who can tell us how things are going each time our code gets updated out in the wild, right? And that communication allows us to increase the performance and the stability of the app, and we're in a way better place. And, you know, it makes life better, right? So it's not hard to get started teaching your app how to talk to you. In fact, it's exactly what we've been doing as a mobile industry for the past couple of years. Right? Teaching apps to talk back through beta testing and through crash reporting tools is a great start. But there's this really big, wide gap between beta testing and my app crashed that we're not yet looking at. And we miss a lot of what our apps could tell us about what's going on out there. So I've been spending a lot of my time recently thinking about this idea of sort of quantifying the subjective user experience, right? And teaching the app how to tell me what people are experiencing as they're working with it, and it's on millions of nodes running this code all over the world. So before I joined New Relic, I spent about 3 years or so building mobile and web apps and doing a lot of sort of startup consulting stuff, and built all these great mobile apps that were really cool. At least I thought they were cool at the time. So to illustrate the way this whole DevOps way can apply to this, I picked 3 reminders from my past of things that didn't go the way I expected them to. The names of innocents have been changed, and this is my prior life, so hopefully we're all safe here. But these were real. I'm going to kind of talk you through these 3 scenarios. They were all real, right? They all actually didn't get caught in testing and did hit during sort of public beta or production, or in one case when a potential investor's son was using the app, right? These are like, just constant long nights and hair pulling trying to figure out why these things didn't work. And that's probably the reason I'm here today talking about how to make it better. So the first one, you take this kind of simple mobile app that talks to an API server that talks to a database. And this app complemented a web-based service product, right? So we had this nice web product, and we said, we need a mobile app for this, right? And the mobile app was just kind of a secondary way of getting at that same information. In this case, usage and the traffic from the mobile app was actually really small compared to our web app. But the people using the mobile app were our critical, most valued customers, right? They had the highest business value to us. So we needed them to have a great experience, because otherwise we're like, yeah, everyone used the web thing, and then there's this other kind of not so great experience on the mobile. We didn't want that at all. So one of the things we did to make sure that we were being really thorough in trying to catch problems was to have a complete clone environment for testing. We would just build internal builds of the app and distribute them to people in the company and a few trusted friends, and use that as a way to kind of bake out changes. And one day we shipped a bug fix to, it was like a .0.1 kind of release that just fixed a couple of little visual tweaks in the app. But soon we started getting complaints about people not being able to log in. And then it was a lot of complaints. And suddenly we realized we had a really big problem, right? We had like none of our customers could log into the mobile app. Bad thing. thankfully, we had New Relic running on the server, and we're like, hey, let's go look at the server. But it looked fine. If any of you use New Relic, this is a server error rate chart, right? It shows a couple of deployment lines there where we had pushed out new code to our servers, but effectively, there's just a big flat line across the bottom that says the server's fine. There were no major changes in the error rates or the throughput of our server. It all kind of looked fine. And so we started downloading the app from the App Store and testing that out, and everything was fine for us too. So we couldn't reproduce this problem that we knew, probably 50% of our customers were hitting. We had no idea what was going on. And this is precisely why we ended up building this New Relic for mobile thing, because monitoring the server can't tell you when there's a difference of opinion between the different layers of your architecture. The mobile app, it turns out, was telling a completely different story about error rates. Nearly 100% of the calls from the mobile app into our API were getting back 401 or 403 errors saying, you can't log in, access denied. But where were all those errors coming from? Anyone guess? Yeah, from the wrong host name, turns out, which you could clearly see in the mobile monitoring's error chart, because suddenly there was this dev host name sitting there that wasn't there before. We shipped a build that was pointing to our test server, right? So of course we could all log in because we all had accounts on the test server and we were all using the same password for the test and the production server. But no one else could log in. And our test server was doing exactly what it was designed to do. It was getting login requests for accounts that didn't exist and rejecting them. So, each tier of your application has its own business logic, right? The mobile app has one expectation for how the world works. Your server has potentially a very different understanding of what's going on and how things are supposed to work. And the healthy behavior in one tier can lead to catastrophic trouble in another. And if you're not watching each of those layers, then you really don't have any tools to solve that mystery quickly. So that's what I like to call the two charts, or the difference of opinion story. But sometimes you don't even have access to the server, right? I was building this cute little messaging app that used Facebook, and if you've never used Facebook to do this kind of stuff, the way it works is your app talks to both your own messaging server and also Facebook's API. And so some of the data passes through your server and some of the data goes directly between Facebook and your user. And this is good, right? Because then we don't have to get in the middle of routing all of someone's friends list from Facebook. And the idea here was you'd sign into the app with Facebook, download your Facebook contacts, and then anyone on that list you could send a cute little message to. It would make like chicken sounds and stuff. And the app had to keep a local copy of all your contact info so that it knew who was attached to which messages and everything. And I chose to use a nice object relational mapping layer to do all the database work in the phone, and it was really slick, right? And I knew that the database on the phone is a very slow thing. You have to be really careful about not doing too much work there because it can really bog things down. So spent a lot of time making sure it was just right, and it was going to be great. And then the synchronizing of everything happened in the background, but there were some features of the app that didn't work until after that sync had happened each time you launched the app. So during beta testing, one of our users reported these extremely long app loading times. Like they'd fire up the app and it would just sit there for like 2 minutes before they could send a message. So we had all this back and forth conversation by email and Skype, and so okay, if I log out and log back in, it works great one time, but then we're back to trouble, right? And okay, let's uninstall the app and reinstall, and it worked great one time, and then we're back to this slow trouble. So we had someone put some custom instrumentation into the server and into our messaging server, and they didn't see anything weird there. So then I made another custom build of the app that could actually instrument the network traffic going to and from Facebook so we could see how big that was and what the response time was. But that was all fine too. It just wasn't that big of a, there was nothing long running that was happening here. So finally I resorted to what I think of as the Hail Mary of mobile troubleshooting. And I happened to be going to San Francisco where this guy was, asked him if he'd meet up for coffee and let me take a look at his phone. So after flying there, getting to the coffee shop, meeting up with him, after 3 text messages and whatnot, hooking up his phone to the laptop, getting a debug build running on it, and firing up a profiler, it took about 45 seconds to get an answer, plus the plane flight and the hour in traffic and everything else, right? Logistics are sometimes really hard. So I looked at this guy, and as calmly as I could, I asked him, how many friends do you have on Facebook? Who wants to guess? I don't know, maybe like 10,000 or something. Like, what? How do you have 10,000 friends on Facebook? I don't know, but he did. I wish I had New Relic. So, we've been working, as any of you who saw the keynote this morning noticed that, we've been talking about and working on this idea of, let's not just look at what the phone talks to, but let's look at what's going on in that app in real time as someone's using it, right? And that's, very soon you'll be able to see that in your own apps, that you'll be able to see what's happening on one person's phone somewhere out in the world, any one person's phone. Because you just can't predict the real world data, right? It turns out that if you have 10,000 friends on Facebook, every time you log into my app, statistically speaking, several hundred people will have changed their profile data. And in my app, that means that you've got to do some 700 database update calls, right? And the code was pretty fast, like 50 milliseconds for a query and update on SQLite is really fast on a phone, but not when you have to do it 700 times. So, the technical solution was to go back and do this whole drop and update thing where you just trash the data and insert new data rather than trying to update what's already there. And it turns out that that was way faster. But to do that, you have to do some denormalizing and get rid of foreign key constraints and all this stuff, which made it a little harder to keep the bookkeeping right. So originally I was thinking, this will be great. It'll be really rock solid and performant and safe. And then I had to delete all of that safety stuff because it was too slow, which meant needing to spend a lot more time worrying about whether that data was going to get out of sync with itself. And that leads to needing more feedback from the phone to know when things are going wrong, right? So feedback from the instrumented app helps you solve these problems a lot faster and without having to go halfway across the country and squat in a coffee shop to find out why someone's not having a good experience. It's my coffee table, or my coffee table book there. So lastly, one more case. You've been here for a while. Thank you for being patient with me as I rattle on. Lastly, I wanted to talk about what happens when you do everything right? You've got this amazing app design, and you've tested it so thoroughly, and you go out and you follow all of the great advice from all of the bloggers who are doing this hard stuff and solving it and sharing their wisdom. And still something goes wrong. Right? I was working with a team on building a photo sharing app, and it was pretty simple. The use case was basically someone would go out, take a bunch of photos of stuff while they were shopping, and then tag them with the store they were in, and put together a little album and share the album, which was viewable on the web. So the demographic was basically people who like to get their friends' advice while they're actually shopping for clothes. It was kind of cool, all right? And so to make it nice, we focused a lot on the whole perceived performance of the app. And that means doing a lot of stuff non-linearly where you don't notice it as much, right? So Instagram had just put out this great article on how they had optimized the photo sharing flow in their app. And you do all this cool stuff, right? Like you start getting a GPS lock before you even show someone the camera. And then you upload the photo, you compress it and optimize it for web viewing and upload it as soon as they say, yeah, this is a good photo, right? And then they spend some time typing in the title, and in the meantime, your GPS is finished, and then you go out to Foursquare to get a list of local stores, and then as soon as they're done with their title and their notes, you pop up the list of local places that they might want to pick from, right? And then all this stuff gets settled in, and by the time they're ready to share it, everything's been synchronized, and all you need to do is go and talk to the server and get back a little link which you share out to the world. It was really smooth. It worked great. We loved it until we sent a teenager to the mall to try it out. So it turns out that somewhere in this app, when you renamed the album that you were about to share, we were touching the metadata on each of the photos, right? And that marked the metadata as dirty and needing synchronized with our server again. And that was by design. It was, it was fine. But we weren't re-uploading any of the photos. It was just these little 100, 200 bytes of metadata for each photo. But we did the updates one at a time in serial, right? So little update, little update, little update, little update, little update. And it worked, remember this? It worked great on Wi-Fi, and it worked great on our 3G phone that we were testing with at the office. And it was all over SSL, so it was nice and secure, and the latency was really not bad. It was 100 milliseconds on Wi-Fi, maybe a little bit more than that on cell. But it turned out that at the mall, where this like 2-year-old Android phone had 2 bars of signal, if you were really lucky, it was way worse. It was like seconds to tens of seconds just to get that SSL transaction round-tripped. And so it was this problem of like a convergence of an unexpected user behavior combined with an unexpected environmental condition over which we really had no control, right? Not the kind of thing you think of testing when you're just, revving through the app and getting excited about how cool it's going to be. So we did some server-side logging and some client-side logging and some code auditing and bribed our test subject with a gift card to go out and give us a do-over. And in the end, we solved it, right? Once you could see what's happening, it's really not a hard problem to solve. You just say, like, well, too many requests is expensive, so let's just batch everything up and teach the server how to recognize a batch. And then you just do one round trip. It takes a couple seconds, but that's kind of something someone expects. And then the problem is solved, right? But you can't test all of these possible permutations of environments and user activities and behaviors and everything. You can't. Even if you tried, you'd need to hold like 200 different cell phones in your pocket while you did this, because each one is a little different. And you could spend a month on acceptance testing and still not catch something like this. So, users will find these bugs like in the first hour, and you can't predict what they're going to do. And even if you do catch it while you're testing, it might just happen once, and you might not really know what exactly caused that problem, right? You say, like, oh, something weird happened. Well, I can't reproduce it. I don't know. So if you saw Lou's keynote this morning, again, you got kind of a preview of how we're going to fix this, right? This is what we're calling an interaction timeline. And it is automatically captured from the phone as someone is using your app, right? So everyone running your app out in the world, we're capturing this kind of data and then reporting in interesting traces that, kind of capture a spectrum of the activity that users are encountering. And in this case, it's showing us precisely what happened over the course of a 68-second long interaction on the phone, which is way too long, right? No one is going to sit there staring at their phone for a minute while the little spinny cursor goes like this. But in here, you can see, there's memory usage, there's networking, there's what's going on the main thread of your app, and then there's all this background work happening down here, right? And in this case, this app is either running on a very old phone or is kind of poorly designed, because if you look at this network thing, it's like, why are we doing all these things all in a row like that? That doesn't make any sense. We could bunch that stuff up and try and saturate the cell radio and get this stuff done much more quickly. Or, as in my example, compress it all into one request that sends a little bit more data with a whole lot less latency. So because this is automatically captured in like real time, you can see, diagnose, and fix the problem before a bug report even shows up, right? I mean, imagine if we've all, maybe not, I don't know, who here has reported a bug about a mobile app to a developer? Or complained on Twitter about how a mobile app isn't working right? All right. Different demographic. Right? Imagine if as a user, the typical experience is like, hey, you have this problem I'm having this problem with your app. Can you fix it? And then you spend like 3 or 4 rounds of email or whatever trying to describe to them what's happening. And they're sending you back these questions and you have no idea what the words in the questions mean, right? And imagine if instead of all of that, like hours of that frustration, you told someone about a bug in their app and they just came back to you and they said, oh yeah, sorry about that. We know exactly what caused that problem and there will be a fix in the next release. So much better. And that's the power of DevOps, right? That's the power of we have immediate feedback on the production operation of our code. The confidence and predictability that that gives you allows you to plan your life, right? And to go home at a reasonable hour instead of pulling your hair out all night. So, to me, I think these stories really highlight 3 key things. One, you have to measure your business level expectations at every tier of your application and make it easy to compare the measurements, right? Just having the data doesn't really help you. It needs to be on screen in a way that you can see when things aren't going according to plan. 2, code instrumentation can tell you what your code is doing, and captured data will tell you why it's doing that. Right? You know your code, and you have expectations about how it's supposed to operate. And sometimes your expectations are like blown away when you realize there's this crazy emergent behavior in your architecture. But more often, it's just you don't anticipate a particular set of data running through that code. And you can guess often enough as to why something's not working the way you expect. But why guess and spend all of that time trying to validate it when you can just see what's going on, right? And 3, even simple software gets really, really complicated when you factor in the operating systems, the hardware, the network links, the cell carriers who do crazy things, and the rest of the world, right? And little embedded processors on your neck. Instead, you have to measure as many of those different factors as you can and get them all into one place so that you can see answers to what's going on. All right, so DevOps it lets you stay agile and manage that risk that happens when you try and move quickly, or the risk that happens when you acknowledge that you'll never be able to test all of the possible permutations. In mobile, you have to make the app your ops partner because there is no ops, right? There's just phones that you're not allowed to touch. And by teaching your code to talk and learning how to listen to it, you can find answers. And answers make for happy users, happy business partners, happy customers, and give you much more time to play. Thank you.